Hello, today we are going to implement the LED bar graph with the PIC microcontroller. So let me just show you what is LED bar graph. See here, as you can see that it is a device which has 10 LEDs. Okay, so let's just select this any of this, and we need a controller. Here we are working on PIC16F877A. So let's just design the circuit here for the simulation. So here is the PIC microcontroller, and now we need to interface the LED bar graph. Just connect each LED with the different pins of the B port, like I have connected the 0 pin to the 1, and similarly I'm using B port to control the LED here. So first of all I am connecting only 8 pins. Okay, and we can change this name also, LED graph. Okay, and this is supposed to be grounded. Okay, so just connect this all and we will ground it. Okay, and now select the ground from the terminal. Okay, so here as you can see that the LED bar graph is connected at the B port. So in the programming we have to initialize the B port as output. So first of all let me just write the main function, void main. Okay, and we need to initialize, we need to specify that the B port is used as the output. So 0x00, which means all the pins of the B port will act as the output, and since here we have the 8 pins, so I have converted these 8 pins in the hexadecimal, from the binary to hexadecimal, using the 8421 codes. I will be using here 8421 codes. I will tell you how to write 8421 codes if you are not aware of it. And now for the infinite loop we are going to use while loop. Okay, and okay, so what do we need here? I'm looking for a program. I'm trying to write a program where this first LED will glow and will turn on, and then the second, and then the third and fourth, and so on. And in this way all LEDs should turn on and turn off one by one. Okay, so we need first of all to define a variable unsigned character. Let's say I'm going to write chaser, because the LED will chase one another. Okay, and there are 8 LEDs, so there will be 8 variables here. And let me just write the variable here for the 1, and see here, as you can see that I have written, let me just highlight this, so I hope it's more visible. So I have just written 0x01, 02, 0x04, 0x08, 0x10. So these are actually the hexadecimal code converted from the binary. Let me just show you how we write this. So as you can see here that we have 8 ports, okay, 8 pins actually. We have 8 pins. So let me just say that the first pin is 1 and all 8 pins are 0. Okay, let me just show here. I know my handwriting is not very good in the paint, but I hope it's quite visible. So here, as you can see that we have 8 pins I have mentioned, and now just suppose that only the first pin will generate a high logic, okay, and the other 7 pins will be low. So how do we convert this? We will write 1 here, 2 here, 4, and this will be 8, okay, and similarly 1, 2, 4 and 8. So here, as you can see that this is 1 and this is the another, okay. So 8, 4, 2, 1, what we will do here, so as you can see that we will have to add all the ones here, okay, and all the ones here. So as you can see that only 1 is 1 here, okay, so we will get here 1 and there are no ones here, okay, all are 0. So here we will get 0 and we will write 0x to represent that this code is going to represent a hexadecimal. And similarly, let me just show you another, that for example that we have 1 here, okay. So as you can see that these 4 pins will not change, and here we are getting 1 around 2, okay. So we will write here 0x to 1, okay. And I am hoping that you are already familiar that how do we write 10, 11, 12, 13 or 14 in hexadecimal. For example, if we have here 1, 1, 1, 1, then if we add all these 4s means 8, 4, 12, 13, 14 and 15. So for 15 we write F in hexadecimal, okay. So in this way we can write the code to specify which pin are we generating high and where we will generate the low. So in this way we have written this, and I am going to implement this one by one in the microcontroller. Okay, so after void main, let me just initialize an integer I, and in while 1 I am going to use a for loop for I equals to 0, I less than equals to 7, I plus plus. Well, this for loop is going to execute the program one by one from this for I equals to 0, which means this code will start running from the zeroth array here, and then it will move on up to 7 and with an increment of 1, okay. And here I am going to write port B equals to chaser I, okay, and let us just implement a delay of around, let's say, 200 milliseconds, okay. So okay, let me just run this, let me just compile this, and there is an error here. Let me compile it again. Okay, so the compilation is successful here, and let me just select this, and let's change the clock frequency to 20 megahertz, and let's run the simulation. So as you can see here that 8 LEDs are running one by one. It is actually chasing one another LEDs. And now suppose that if you want to run this in such a way that first of all this LED should turn on, and then it should chase in the upward direction, not in the downward direction. So you could just change the program here from I equals to 7 and up to greater than equals to up to 0, and decrease the integer I by 1. Okay, and let's run it again. Okay, and I have run the program has compiled successfully, and now let's run the simulation again. So here as you can see that now the LED is chasing in the opposite direction, in the upward direction. And similarly you can write your own code in, for example, if you want to turn on the second LED at first, and then the fourth LED, and then the sixth LED. So in this way there are many possible combinations which you can try. Okay, thank you.